Hello guys, welcome back to the channel. This is Rosario Borgesi and in this video we will discuss the ERC1155 standard that allow us to mint and manage both fungible and non-fungible token. We will also make a practical example on the base Sepolia chain and we will test our smart contract with the Remix. So let's get started. This is the Medium article that I have created for the video, and let's start by understanding what is the ERC1155 standard. This standard is born to create a single interface that allows to mint and to manage multiple types of token. So we have a single contract that allow us to deploy not only fungible tokens like the ERC20, but also the non-fungible tokens like the ERC721, or also other configurations like the semi-fungible tokens. So while prior to this standard we had the ERC20 standard that only managed the fungible tokens, and the ERC721 that managed the NFT, the non-fungible tokens. Now we can incorporate all these tokens inside one contract, so that allows to mint multiple tokens. So for example, earlier if we had to for example deploy multiple fungible tokens, we had to deploy multiple ERC20 smart contracts, and likewise if we had to deploy multiple non-fungible tokens, so ERC721, we had to deploy multiple smart contracts of this type, while in this case we only deploy one smart contract that allow us to manage a variety of tokens. This of course allows to reduce the cost and the complexity of the transaction, and for example we could send a sword, a shield and some gold coins to a friend effortlessly all in one transaction. This ERC 1155 that has been highly beneficial for gaming application is very versatile, and it seamlessly supports a wide range of token types, including currencies, collectibles and specialized tokens. It also introduces a safety mechanism that enables the recovery of tokens mistakenly sent to the wrong address. And so this marks a substantial advancement over the earlier token standards, which are ERC20 and ERC721, offering users greater security and confidence. Here there is a comparison of the three standards. So the ERC20, it is the standard of the fungible token. ERC721, it is the standard of the non-fungible token. The ERC1155, it is the standard that allows to manage both fungible and non-fungible token on the same contract. As you can see, the ERC20 use case were mainly stable coins, altcoins and utility tokens, while the use case of the 721 were digital art, collectibles, in-game assets and other NFTs, while the use case of the 1155 are both fungible and non-fungible tokens. So like every standard there are some interfaces and smart contracts which are the actual implementation of the methods and that are defined in the interfaces. All of these are provided by OpenZeppelin, And so the ERC1155 comes with the three basic interfaces, which are IERC1155, IRC1155 metadata URI, and IRC1155 receiver. So the first one, it is the core interface of the 1155 standard and defines the fundamental functionality. The metadata URI specifies the URI method which retrieves the URI associated with a specific token ID, while the receiver interface is the interface that smart contracts must implement to handle incoming ERC1155 token transfer. So the basic interface defines the following methods, which are balance of batch. So this is used, as we will see later on, to get the balance of an account for a specific ID. This allows to get the balance of multiple accounts for multiple IDs. These two are used to set this is used to set the approval for all tokens. This is used to query the approval for all tokens of a specific address. Then there is of course the safe transfer from, which is used to transfer a token from one address to another. This allows to the safe batch transfer from send multiple tokens from one address to another. And then there is the last method, which is the support interface. So we have discussed pretty much all this method. There are also other methods to, for example, mint and mint batch that are internal methods that are defined by the ERC1155 smart contract that we will see later on. And so if you want to check out the implementation, you can find them at this repository. So here you can find all the it is in this folder. This is the interface, okay, where you can see all the methods that we have listed before. Here there are the implementation, and are in this smart contract are implemented the method that have been defined in this interface. There are also other methods that we will see, we'll test later. For example, this method to mint new tokens, or this other method to mint a batch of tokens. To, of course, as you can see here, it takes in input an array of IDs, and also it has an array of values. There are also likewise there are methods to burn a single token or to burn a batch of tokens. So these are all the methods that are defined by this smart contract here, that we will see in greater detail when we will test our ERC 1155 method, 1155 smart contract that we will create. So coming back to our discussion, there with the standard ERC 1155 also come some and also I forgot to tell, there is also the OpenZeppelin page where you can find all the documentation related to this standard, because this is the standard. This company provides the standard smart contracts, which are approved by all the community. So there are also some extensions that have been created. to support the ERC 1155 like it has been done for the ERC20 or the ERC721, which are the ERC 1155 posable, which enables pausing of token transfer, minting and burning, and this is useful in scenarios like delaying trades until an evaluation period ends or activating an emergency freeze in case of a major issues. Then there is the burnable extension that allows token holders to destroy their own tokens or tokens they are approved to manage. The supply extension that tracks the total supply of tokens per ID. This is obviously particularly helpful when distinguishing between fungible and non-fungible tokens. And there is also the URI storage extensions that provides the URI management for tokens using on-chain storage, and this is inspired by the ERC721 URI storage extension. Additionally, there is the utility contract called Holder, which is a simple implementation of the interface that we have seen earlier, ERC1155 receiver, that allows a contract to hold the ERC1155. This is useful when you want to send tokens from one contract to another contract. Let's imagine that we want to create a smart contract that manages the vehicles in a video game. So there are for example, I took inspiration from GTA 3. There were multiple types of vehicles. Some types of vehicles were present in larger quantities. Some other vehicles were present in lower quantities. And for example, I imagined also that there was only one example, only one train in the game. So we could say that the vehicles that were created in quantities that were greater than one could be implemented as fungible tokens, because each vehicle of the same type is always equal to the same vehicle of the same type, while for the vehicle that was present in just one, for which there was only one in the game, like the train, we could implement it like an NFT. So this is the smart contract that I have created to implement this type of vehicles of our video game. To start creating the smart contract, I used this wizard by OpenZeppelin, which is very useful. So I selected the ERC1155, the name of the token, which is GTA Vehicles. Okay, since it is an ERC1155, this wizard automatically creates a smart contract that inherits from the ERC1155 contract, and also inherits from the ownable contract, because here it is selected ownable. This type of smart contract allows to set the owner of the smart contract. So here in the constructor we are passing as an argument the owner of the smart contract, which can be changed later on. And to the ERC1155 we are passing an empty string, because here we are setting the URI, but we don't need the smart contract to handle our URI. We will handle ourselves, as we will see. And here we are calling also the constructor of the ownable smart contract. So here we are specifically setting the owner of the smart contract. So we don't care about this function because we will not use it. And here you can also add some other feature. For example, if you want the smart contract to be mintable, you check this box, and it creates automatically for us the mint function, which, as you can see, calls the internal function of the ERC1155 mint function, and likewise the mint batch function automatically calls the mint batch internal function of the ERC1155 contract. You could also add, for example, the supply tracking, so now the smart contract inherits also from the supply extension. And of course the smart contract is automatically updated. You could also add some other feature, for example, pausable, burnable. You can this wizard allows you to customize the smart contract as you see it fit. So once we have done this, so we have created a basic smart contract, we can improve it and change it as we like. For example, in this case I have added the name variable because this is used by OpenSea to give a name to our collection. Here I created also a token counter, which because in my mind I wanted to create a smart contract that allowed to mint multiple tokens even after the smart contract was deployed. So in this case, in the constructor I have added some changes. As you can see here, we mint, so the constructor, it is called when the smart contract it is deployed. So at the time of deployment we are minting 10,000 tokens of ID0, which corresponds to our car, the Sentinel. And we are also setting we are also calling the set URI method of the storage of the URI storage extension to set the URI related to the token 0 of ID0, and I am using this IPFS link here. So the URI, it is used by OpenSea to allow to associate metadata to our token. So we are saying that the token of ID0, in this case the Sentinel, is associated with the JSON that has been uploaded at this URL on IPFS. To make things simpler, I have used Pinata, which is an IPFS provider. So what I've done is that on my account, after I created an API key, I've uploaded the 5 images that you can that you see here, that was seen earlier in this picture. So we have it, for example, let's add more rows to the page. The first image is 0.jpg. Okay, we can see it. It is the Sentinel, the first car. So I have firstly uploaded this JPEG to Pinata, and then I've taken also this CID, okay, which is the the hash that identifies in a unique manner my picture, the 0.jpg picture. So I took this hash here and created a file of metadata related to the to the token of ID 0 that I have called 0.json, which is, as you can see, has some information. This has been created by with ChatGPT. For example, the name, it is Sentinel, the description, a classic luxury sedan from GTA 3 favored by mafia bosses. Here the image, it is the URL or the IPFS link that we have seen earlier. So the CID that we of the 0.jpg file that we have already uploaded, and then some other attributes. So this file, this JSON files identifies the metadata associated to the 0 token. So then I took the CID that was associated to this file 0.json on IPFS, and I put this link here, as you can see here. So when I call this function here, the setURI function, this smart contract here that we can also check, as you can see, this has a mappings that maps for each token ID the corresponding URI. So for the token 0 we have the corresponding IPFS URL, which is this one, because we are calling the function here setURI. Okay, then once we have done that, this has been done, of course this process has been done for all other tokens, because we have here four types of tokens that are minted in the construction. So this is the Sentinel, the Kuruma, the Banshee, and also the Infernus car and the train. These 4 tokens are minted when the smart contract it is deployed. So for example, here we have created 100,000 copies of the Kuruma and only 1 copy of the train. So the train is an NFT. So while, for example, the Sentinel, it is a fungible token because the value here is greater than 1. Also the Kuruma, the train is an NFT because we only have 1 copy of this token. The same goes for the Banshee and also the Infernus. So once we have deployed these tokens, we here must define a function called URI. So this function, in this case, very simply returns the URI associated for the specific token ID. So that's the reason why I've created the token counter, so we cannot call a token ID that does not exist. We cannot call this function on a token ID that does not exist. Then we have the main function that I have updated a little bit because I added the set URI, because this function in my mind was created here to allow minting a new type of token, as we will see when we will create the Mr. Whoopi type, the Mr. Whoopi vehicle. While the mint batch function has been left untouched, and same for the update function, where they are the same that have been created here by the wizard. So now that we have discussed this smart contract, we can start to test it. So as you can see here, the contract has already been compiled because I have the auto compile here. We can deploy our smart contract. So I can choose log in to my MetaMask account. If you are new to MetaMask and to I will use also Base Epolia as a test network. If you are new to this, please check out my video on MetaMask. So this is my account. This is the first account that we will use to deploy our to set this account as the owner of the smart contract that we are deploying. So here we choose injected provided MetaMask. We are so deploying this account, this smart contract from this account FE28, and this account is will also be the owner of the smart contract, because here we are passing this variable to the constructor. So once we deploy the contract, of course it asks us to confirm the transaction. Okay, so the transaction has been deployed. Here we can see we have our smart contract, so we can now test it. For example, we can say if I copy my account, what is the balance of my account for the ID, for example 0. Okay, the result is 10,000 because we have deployed here 10,000 tokens of ID 0 to the to message.sender, which is the receiver. Here, as you can see, this is the 2 is the receiver, and message.sender means that these tokens go to the account that is calling the constructor. So in this case it is my account here, because from this account I'm deploying the contract. Okay. We could also call the balance of batch function. For example, we could write, I want to check the balance for the account, always my this account, because we have deployed all this contract to this account. I want to check the balance for this account, my first account, of the ID, let's say 1 and 2, of the tokens of ID 1 and 2, let's call it. Okay, as you can see, this account FE28 has a balance of 100,000 of token 1, and here you see Y, and also has a balance for the token 2 of 1, because here we have deployed just one. This is an FT, just one train. Okay, now another thing that we can try is to mint, for example, a new token. For example, let's see that I want to mint to my second account, which is this one. Let's see if we here also it changed this account here, but we cannot call the function of our smart contract from this other account, because the FE28 is the account that owns the smart contract. So from this account, let's say that we want to mint to my second account an amount of 3 Mr. Upi tokens that I have already deployed here. As you can see here, there is the file 5.json of Mr. Upi, and the file 5.jpg, which is this one. And here we can say as data we pass obviously 0x00, because we are not providing an ether. As the token URI, we have to do this as we did earlier. We copy the CID of the file 5.json. We go here, and here we write like we did here, IPFS : / we paste the URI, and we then transact, send transaction. Here we confirm. Okay, the transaction failed. The transaction failed because it has changed my account here. I don't know why. I changed it to this account because I don't know, every time Remix changes the account. Since he was trying to call the function with my second account, which is not the owner of the smart contract, the transaction reverted. So here, let's try to call it with my first account again. Let's see if now it goes. Transact. Account 1 now, okay. Okay, now the transaction has been confirmed. Okay, so we can, for example, check the transaction here. We take the transaction hash. We go to base Sepolia scan. Okay. So as we can see here it says that it has been created the token of ID3. So we have called this method by the method is called this way. It does not give us the name, but however here we can see that it has been created the token of ID5 from 0 to my second account B35. And also if here tells us some more, no. Okay, so the token has been created. Let's now check, for example, the balance. So we say, for example, balance of, let's say here, let's copy this account, which is the second. Balance of this account of token of ID 5. There are 3 tokens. Okay, so this token has been minted. We could also, for example, mint more copies of tokens that are already present. For example, let's say that we want to mint to my second address, which is this one. We want to mint some new tokens of ID 0 and 1, because for example we have seen that in our games we need more car of type Sentinel or Kuruma. So I can put here the amount of new tokens that I want to create. Let's put here, for example, 100 for the first and also 100 to the second. As data we always pass 0x00. Okay, the smart contract, it is okay. Transact. Confirm. Okay, transaction confirmed. If I now try to check, here we can also check the transaction as we did earlier. Transaction hash, copy. We go on the base scan Sepolia. We put the transaction hash. Okay, call the function mint batch. I have created this token, 100 token of ID 0 to my second account, 100 token of ID 1 to my second account. Now let's double check this by calling the balance of batch method. Here we put we call the mint batch, so we put the second account that should be this one. Let's delete everything because it is a little bit hard to do. So we put 2 times this account, and we want to check the balance of type. We have said 0 and 1, so 0 and 1, let's call it. So the output is 10, 100 and 100, so it is fine. So another thing that we can try is to make a transfer. Okay, so safe transfer from this only transfer a single token. Okay, so let's say that we want to transfer from I don't know, the first account, which is this. Let's close some windows, otherwise I get confused. Okay, let's call the safe transfer from. So from my first account to my second account. I want to transfer, for example, for the ID 0. I want to send, I don't know. No, let's try with another account that has no token at all. So we are, so it is easier to check the balance. So my third wallet, my third account that was never been used. So we send the ID 0, we send, for example, 100 tokens, data, we pass of course 0x00, is calling from the first account, fine, transact, confirm. Okay, now also we can check the transaction on Sevolia. Okay, you can see it has called the safe transfer function from FE28. This is the address of the smart contract, and the tokens, 100 tokens of ID 0 has been sent to my third account. So now if I get back here, if I check the balance of this of my third account for the ID 0, okay, I find 1000. Okay, fine. We could also, for example, send, let's say, a batch of tokens. Let's say that we want to send to my second account from my first account here. We want to send the ID this time, for example, 0 and 1. We want to send, for example, just 1 of the ID of ID 0 and 100 of ID 1. As data we pass 0x00. We execute the transaction, confirm. The transaction has been executed. We can copy the hash also here. We check the transaction on the scanner. So we called the function safe batch transfer from. The recipient, it is always my third account. We are transferring 1 token of ID 0 and 100 token of ID 1. OID1. So to check, we can also check the balance. We can call balance of batch. Let's put my third account here. We want 0 and 1, call, okay. So 101 and 100. It is also possible to check our collection on OpenSea. For example, here we take the address of the smart contract that we have deployed. We go to OpenSea testnet. So we paste it here. This is our collection GTA vehicles. This is a marketplace to buy and sell NFTs, tokens. So here we can see that our collection it has been found by OpenSea. Here we find all our the tokens that we have minted. As you can see here, there are also the quantities of each tokens that have been minted. And here, for example, you can find some information, the description. These are all information that have been taken from the JSON file that we have uploaded on IPFS. So here there are some details, as you can see, the contract address, the token ID, the token start and is 1155, the chain base Evolia, okay. So guys, we have reached the end of the video. I hope that it has been useful. If you have any questions, please drop a comment and I will reply as soon as I can. Thank you for watching and see you in the next video.